everyone, welcome to Teacher Plus. So today we are going to discuss an interesting topic, that is Mendeleff's periodic table. And what is a periodic table? It is a classification of elements. And what is classification? Classification is arrangement of elements based on their similarities and differences, right? And classification of elements is very important, and because this is very important, many scientists have tried to classify these elements. Here the evolution of periodic table, and here the classification of elements has evolved over time, driven by the need to organize elements better based on their properties to understand chemical behavior better. So here the elements are over time, by the need to organize elements, as over time the number of elements increased, the need for classification also increased. And why are we classifying these elements? To understand their chemical behavior and to know their similarities and differences easily. Okay, now initially elements were classified simply as metals or non-metals. However, with the discovery of atomic weight and the recognition of recurring chemical properties, scientists like Dobereiner, Newland and Mendeleff introduced more structured classification. So earlier elements were only classified as metals or non-metals, only these two. But with the discovery of atomic weights and the recognition of recurring chemical properties, so earlier they were only classified into metals and non-metals, right? But since atomic weight came into play, and also when they noticed that there was a recurring pattern, like there was a repeating pattern in these elements, they want to classify these elements based on them. And in this classification, Dobereiner, Newland and Mendeleff introduced more structured classification. So the classification they made was a more structured one, like more neatly explained one. And in that we are going to learn about Mendeleff's periodic table. Now here Mendeleff's periodic table. In 1869, Mendeleff, a Russian chemist, proposed a periodic table that organized elements based on their atomic weights and properties. This table marked a major advancement in understanding the relations among elements and was a significant one. So Mendeleff was a Russian chemist, and he proposed a periodic table that organized elements based on their atomic weights. So he organized the elements based on their atomic weights and properties, and this was also a significant one. And here his periodic law, the table's periodic law was: the properties of elements are the periodic functions of the atomic weights. So the periodic law of Mendeleff formulated the periodic law, which states that the properties of the elements are the periodic functions of their atomic weights. Here atomic weights are important, okay? And recurring pattern. This law implied that when elements were arranged in order of increasing atomic weight, elements with similar chemical properties appeared at regular intervals, creating a recurring or periodic pattern. So here periodic means repeating. So periodic pattern means there was repetition of these properties, okay? And this law implied that when elements were arranged in the in the order of increasing atomic weight, understood? Like they were arranged in the increasing atomic weight, and they showed like periodic pattern, like similarities at repeating pattern in regular intervals. And this is a periodic pattern, which means the elements properties were repeating in a pattern. Okay, and he classified these elements based on that factor. Here this one is a Mendeleff's periodic table, and we are going to learn about this periodic table. Here These are the salient features of Mendeleff's periodic table. The first one is arrangement by atomic weight. As we know earlier, he said that he arranged the elements by the order of increasing atomic weight, right? Here, Mendeleev organized elements in order of increasing atomic weight, noting that properties recurred at intervals, which means here recurred means repeating. So he noticed that the properties of these elements are repeating at regular intervals, and so this is the arrangement by atomic weight. He noticed the pattern at which the elements were repeating or recurring, and he arranged the elements by that factor. And here the second one is groups and periods. The table was divided into vertical columns called groups and horizontal rows called periods. Here, so this is the Mendeleff's periodic table. As we read right now, here the vertical columns in these groups are called, vertical columns in this table are called groups, and the horizontal rows in this table are called periods, right? So in this table, what are the vertical columns here? See, these are the vertical columns, right? Here, these vertical columns are called groups, which means in this table, all these vertical columns one by one are called groups, and the horizontal rows are called as periods. Here the horizontal rows, you see this? The horizontal rows are called as periods. And one more point is that in these groups in Mendeleff's table, like let's say this is a group. This one group was divided into two subgroups, subgroup A and B. As you see here, subgroup A and subgroup B. So in one group there were two subgroups named A and B. So once again, the vertical columns in this periodic table are called groups and the horizontal rows are called periods. Okay. So the third one, prediction of new elements. Mendeleev left gap for elements that had not yet been discovered, predicting their existence and properties. So while Mendeleev was arranging his, classifying the elements and arranging his table, let's say this is the table for now, and let's say he was arranging elements like this with increasing atomic weight like this. But while he was arranging these elements, he noticed that the element which is supposed to be here is showing similar properties with this group, and the element which is coming here is showing similar properties with this group, which means they are being misplaced here, right? Which means this element should come here and this element should come here, which means the element which is supposed to be in this group, like in this place, is missing. So he thought that new elements are going to be discovered in future, and few elements are missing because of that. So he left gap for those missing elements in his table. Not only leaving gaps for this element, he also predicted the properties of that missing elements. Like at that time, these missing elements were not yet discovered, but he predicted the properties of those elements. For example, here you see gallium and germanium. He predicted the properties of gallium and germanium, which were not discovered at his time. See here in his table, you see here gallium here and germanium here, and he at that time, as these elements were not discovered, he don't know what to call them. He called them Eka aluminium, gallium is Eka aluminium, and germanium is Eka silicon. Why? You must be wondering why, right? Here Eka means one in Sanskrit, And here, why is aluminium and silicon brought up in this? Here, gallium is aluminium is above gallium, and germanium silicon is above germanium. So they were called eka aluminium and eka silicon. So Mendeleev predicted the properties of missing elements which were not even discovered at his time. So he is such a great scientist for this. And the fourth one is correction of atomic weight. Mendeleev adjusted some atomic weights to fit his table's periodic pattern, which helped correct earlier in occurrence. So at his time, atomic weight means equivalent weight into valency. So let's say the valency of a certain element is x and the equivalent weight is y. So xy is equals to here atomic weight. But imagine you took the wrong valency of that element and multiplied it with the equivalent weight, we would get the wrong atomic weight, right? So this happened with few elements, and Mendeleev correct these elements valencies and multiplied it with equivalent weight and found the correct atomic weight of that element. And the fifth one is, so this is the correction of atomic weights, and the fifth one is accommodating similar elements. Here Mendeleev grouped elements based on the similarity in properties, sometimes placing elements slightly out of strict order of atomic weight to better align similar characteristics. So as we know, Mendeleev arranged these elements by the increasing order of their atomic weight, right? But sometimes to align his similar characteristics of the element, he sometimes went out of this strict manner of arranging the elements by increasing atomic weight. Okay, that one is they are called anomalous series. For example, this one, tellurium and iodine. Here Mendeleev placed tellurium before iodine, even though iodine has lower atomic weight than tellurium. So here, since tellurium has more atomic weight than iodine, by the increasing order of atomic weight they should be placed, right? But here tellurium was placed before iodine. Why? Like here tellurium weight, atomic weight was maybe 126.7 and iodine was 126.4, I think. So whose value is bigger here? Tellurium, right? But he placed tellurium before iodine. So he broke the rule, like the increasing order of atomic weight. Why? To match his similarities in that group. But later here you must think that this is wrong, because he said that he arranged the elements with the increasing order of their atomic weight, right? And you think this is wrong? No, it's not, because at that time they only know atomic weights, but now we know atomic numbers, which means the number of protons in an atom. So now that we know atomic numbers, that we know that tellurium has a lower atomic number than iodine. So his decision to put tellurium before iodine was totally correct. And the similar example is, the other example of this is cobalt and nickel. Cobalt has a slightly higher atomic weight than nickel, but due to property similarities, Mendeleev positioned them to match group similarities rather than strictly by atomic weight. So he did the same thing with this, just like tellurium and iodine. Okay, he sometimes put them based on their similarities rather than the increasing order of their atomic weight. Okay. And next, the limitations of Mendeleff's periodic table. His Mendeleff's periodic table was way better than many scientists' classification until then, but there were few limitations of Mendeleff's periodic table. Let's see what they are. Inconsistent placement of elements. Some elements like cobalt and nickel could not be neatly arranged by atomic weight alone. Mendeleev had to deviate from strict order in some cases to maintain property grouping. Just like we discussed earlier, instead of arranging these elements in a strict order of increasing atomic weight, he sometimes have to go out of the order to maintain the property grouping here. Okay, and the unclear position of isotopes. Here, isotopes of elements with the same atomic number but different atomic masses could not be distinctly placed in the table based on the atomic weights alone. So in his table, the position of isotopes were not really clear here. And other limitation of Mendeleff's periodic table is no place for noble gases. So here, what are noble gases? They are inert gases, right? They have stable configuration. And what is stable configuration? Stable configuration means having light valency electrons in the outermost shell, right? And sometimes two for only helium. These are duplet and octet configurations, right? So noble gases are stable elements and they don't react with any elements. So after a long time, these noble gases were discovered, and Mendeleff's table could not accommodate noble gases like helium, neon, argon, as these elements were discovered later and had unique inert properties that did not fit into existing groups. So as they are stable already, unlike other elements, they have unique properties, right? But in Mendeleff's table, there was no place for noble gases like helium, neon, argon, xenon, krypton, radon. So there was no place for these noble gases in Mendeleff's table. Okay, and no explanation for atomic structure. Mendeleff's table was based on atomic weights and did not account for atomic structure and electronic configuration or atomic number, all of which became central to the modern periodic law. So here, right now, we are following the long form of periodic table, which is the modern periodic table, right? And by the modern periodic table, we mostly consider the electronic configuration, but in Mendeleff's table, it was totally based on atomic weight and did not account for the atomic structure here. So this is also one of the limitations of Mendeleff's periodic table. And here, periodic law limitation. The periodic law based on atomic weights and was incomplete. Later, Henry Moseley discovered that atomic number rather than atomic weight was the true basis of periodic behavior, leading to the modern periodic law. So, who gave the modern periodic law? Henry Moseley, right? And here, Mendeleff's periodic law was that the properties of the elements are periodic functions of their atomic weights, but now we know that they are the periodic functions of the electronic configuration, large shell configurations, right? So this is also one of the limitations of Mendeleff's periodic table, and these are the limitations of Mendeleff's periodic table. And here, in conclusion, Mendeleff's ideas and thoughts were very great in this classification of elements. And here, Mendeleff's periodic table was a groundbreaking tool in chemistry, setting the stage for the modern periodic table based on the atomic numbers. Its limitations eventually led to a better understanding of atomic structure and the role of atomic numbers in determining the chemical properties. So in Mendeleff's periodic table, he arranged the elements based on their atomic weight, right? But now we are arranging the elements based on the atomic numbers. Even though he took atomic weights, he did a lot better classification in his time. And not only that, his classification gave many ideas and thoughts for the next generation to make a more clear version of this periodic table. So by this we understand that Mendeleeff is such a great scientist, and by his discoveries we got to know a more clear version of this periodic table, right? And this is our topic for today. I hope you understand. Thank you.